Let's wait for others to join and then we will start our tutorial. Let's wait for a couple of minutes so that everyone can join. Otherwise, they come in between. I usually take like 10 minutes for everyone to join so that I have no, I don't admit in between. That's create a problem sometimes. So we just starting now. I just share the screen. Share the screen. Wait a second. Can everyone see the screen now? Everyone. All right. Yes, I think it's visible. Okay. So let's go to the book. So we are just solving some questions based on some methods. So last time we have seen how to find the condition number, how to use Cholsky method. If I go back and see that, we have discussed the norms as well. So if you guys have problem with that, just let me know. I have a bit cough. Okay, so we are going to discuss a bit more about the iterative methods. So I just write here. So last time we have discussed non-iterative non-iterative methods, and this time we discuss iterative methods. Of course, to solve ax equal b, find x given. Okay, so that we gonna do this time. So the question is, how we gonna do this? All right. So if I go to the book, yes. So iterative improvement of solution is, I just start with one methods. A general linear iterative method for solution of system of differential equations may be defined as this: xk plus 1 equal h times xk plus c. And here you say that, so you kind of find out what is the iterative method means is, like in the earlier cases you have seen that maybe xn plus 1 may be dependent on previous xn plus some times of constant, some constant. Yes, so it's kind of an iteration, like you update. Suppose you are given the value at x naught, which is 1, then you can find easily what is x2 is, x1 is, and then x2, x3, and so on. So given the value x naught, you can find out x1, x2, and so on. So that is called as iterative method, right? So that's all. So in this case also you need to write something like this, and then you just try to say that your xk converges to the exact solution x, which is a inverse b. All right. So that's what we say here as well. So when it will converge to the exact solution is that xn converges to x when n approaches to infinity. So it's kind of complicated language, but you don't need to remember it anyways. So I just come with one method that we're gonna discuss today. So that is called as Jacobi iteration method. In this, how you write the system of equations. So I just write down less that one. Let me do that. Right, I explain. So first method is your favorite method, which is an initial method that you can easily Jacobi iteration method. So what we gonna do in this? Suppose you have a system of equation kind of ax equal b. I just use the white page. I don't like this. Why is this not changing? This is stupid. There is no way to change, is it? Okay. All right. Suppose you are given ax equal b's, and I'm taking a kind of a is a 2 by 2 matrix. Suppose then I can list the entries of a as this: a11, a12, a21, and a22. And you have x1, x2, which is same as b1, b2, right? So you don't know about the solution of this system. So you just need to find out what is x in this case. So how do we do that? Suppose you are given some initial point, say x naught. Let's say it is x naught, which is some kind of initial point, x naught 1, x naught 2, and it is given to you. Then how do you find out? You have to convert in this form. So how do you do that? Let me take another page. Yes, now it's coming. Right. So you just try to shift your x1. You just find out what is x1 in this case. So what is that? So I can write a11 x1 plus a12 x2 is b1, and x1 is b1 minus a12 x2 divided by a11, keeping a11 non-zero. All right. So you have x1, and similarly you can find your x2, which is b2 minus 822 x2. Sorry, a21 x1 divided by a what is that? A22. All right, and this is a22 is non-zero. So in this case, you say you replace this by this one, which is say I just say x2 as y2, something like this. Then it is like xn and yn, which is dependent on this is yn minus 1, and this is divided by a11, and this is y, this is not y, which is xn minus 1 divided by a22. And you know these values, xn minus 1 and yn minus 1. This is your x dot y dot given. And find x1 y1. Is this clear? And you can similarly do the same iterations. So that's what it says. You don't need to update. So here if I go, then it is also saying the same thing. You keep all the things away from x1, x2, xn, and then use the thing. So you can write finally in this way, where xk plus 1 is this. So I would say, just try this question and let me know what is going on. Is this clear, everyone? I cannot hear. Yeah, I think so. It's clear then. Just try this one and try to find out the values of A1 x1. So just consider this system of equations and then try to find out what is your first iteration value. So find find first iteration using Gauss Jacobi method. So your system is this one, just use this one and try to find out. Not more than 5 minutes. All right, have you tried that? Okay, if yes, then let me go with the question once. Okay, so the question is 2x1 minus x2. All right, so suppose I take a random equation kind of this 2x1 plus x2 equals to 1 and 5x1 plus x2 equals to 5, say. Then how do you find that? So x1 is just from this equation you try to find out what is x1, which is 1 minus x2 divided by 2. And from second equation you try to find what is your x2, which is 5 minus 5x1. So you have in this case the values of x1 and x2. So the first initial point, so I just say that x1 y1 or x1 x2 is your x1 y1 in this case. All right. So x naught y naught is given to you as 1 1 suppose. Then what is your x1 y1 x2 y2 and so on. So to find x1 y1. So if you go in the previous slide and see here, yes, so x1 is 1 minus x2 by 2, which is just x1 is 1 minus y1 divided by 2 and x2 is 5 minus 5 times x1 and x2 is in this case it is the next iteration, so it is x1 and y1. So your next iteration value is x1 y1, which is 1 minus y1 by 2 and y1 is given to you 1, so it is just 0. And here as well x1 is your 1, so it is 0. Is it clear everyone? I think so it's clear then. All right. Okay, so that's they are using. So I just say about something about the trick, but what about Gauss-Seidel iteration method? Yes, so I will let you know the trick later on, but let's go with the method first. I just take a new slide. So it is Gauss-Seidel. Anyone knows the difference in between Gauss-Seidel and Gauss-Jacobi method? Anyone? If you have seen the lectures. Okay, yes, then it's just suppose you have a system of equation like, so I just write in x in terms of x1 and y1. That would be more convenient kind of system. So it is your x in terms of x and y. So x plus y is 2, and suppose your x minus y is 1. Done. So suppose you have given x naught y naught, which is kind of 1 1. Then you have to find x1 y1. So same procedure, but a little twist. So x1 is 2 minus y naught, the previous value, and y is y1 is x1 minus 1. So I haven't taken x1 instead of x naught. I have taken x1. So major change, major change. Have you noticed this? Anyone? Is this clear? That you are updating your values after each iteration. That is very clear. So like this, suppose x1 k plus 1 is dependent on your previous values x1, x2, and xn k, and hence x2 k plus 1 is also dependent on the previous values, but it is also taking x1 k plus 1 into account. And similarly, you have to do for xn k plus 1, and that's the same thing that's going on. But you need an updation. So the major difference you see between Gauss-Seidel and Gauss-Jacobi is kind of an iteration, and it's just assuming that you are having the previous updation in the previous iteration. So you just take x1k plus 1 instead of xk over here. And similarly, you are doing that same. So that's kind of more faster as compared to Gauss Jacobi method because it's like you are updating every value at each time, right? So it's kind of more faster as such. I think so. I don't know the way like proving the convergence of that. Maybe I will see that later on. Or is it in your syllabus? I don't know. So just spend some time in solving using Gauss-Seidel iterative method, such type of system, and try to find out your first iteration and give it a go. Just try that. All right. I just wait for another 5 to 7 minutes. Yes, have you tried this one? And just try. So I hope you have done that. And similarly, you can do this. I just go with. So here you can, so there is also another procedure that you need to remember. Like there is a kind of shortcut that you can remember. So suppose you have kind of system of equations like this. You can find LDU from this A. You can construct A from this and then use this formula to find out your next iteration value. That's it. So this is kind of nice thing. So I just show you here. So suppose you have same system, um, this one, and you have to find out what is LDU and B. So B is just your 2, 1. A is just your 1, 1 and 1 minus 1. So what is your L? L is just your 0, 0, 1, 0. D is just your 1 minus 1, 0, 0. And U is just your 0, 1, 0, 0. So that is your LDU. Once you have LDU, so I just write here. In case of Gauss-Jacobi, in case of Gauss-Jacobi method, you just write this one. Minus D inverse L plus U and D inverse B. So H is that minus D inverse and your C is it that same? I think so. This is yes. So this reduces to this kind of system. Xk plus 1 is H times Xk plus C. So in Gauss-Jacobi method, H and C are this, but in Gauss-Seidel, your H is minus D plus L inverse U. And the other case is, what is that? D plus L inverse B. So you just find out LDU and just use this method to find out your first iteration, second iteration, and so on, given what is your first iteration values. Is this clear, everyone? All right, if that's clear. So you learn the two methods, Gauss-Jacobi and Gauss-Seidel method, to solve the system of equations, right? So next method that I'm going to discuss, oh, there is some kind of convergence analysis that we're going to discuss now. So I just go with the main thing. So there is a theorem which says that this one, the iteration method of any form for the solution converges to exact solution for any initial vector if norm of h is less than 1. Okay. So if you satisfy this condition, then your iteration method basically converges. All right. So that is one condition. So I just write here. So if norm of h, any norm, whether it's 2 norm, 1 norm, any norm, if it is less than 1, then you say your method converges, means how close it is from the difference is less than how close this number, very small number, after a certain point. Is this clear? And then there is another thing which says that, so this is a necessary. If your method is converging, it should satisfy this condition. If it is satisfying this condition, your method is converging. So it's just other way around. So you just say that eigenvalues of h are less than 1. Sorry, absolute eigenvalues. So lambda h should be less than 1. It should be less than 1, then your method is converging. All right. So I just go strictly less than 1. It should be. There are some proofs for that. Okay, so there is one question that you can try. Consider the system of equation, example 3.11, for which values of A, Jacobi and Gauss-Seidel methods converge. Okay, just try this first part only and let me know. 5 to 7 minutes for that. Yes, so if you have tried this, just let me know. Okay, so you can write such system into this. So I just write this one over here. So what is the system? 1 minus a 1. Okay, so the system is whites here. Problem is with my touch screen every time. It's just screen up. Oh shit. I'm very sorry I got disconnected because of some issue. I'm back. Just share the screen again. There's some problem going on. All right. I hope the screen is visible to you. Okay. So this is your question, and I'm just trying to write down here. So it's like 1 minus a1, and you have xy, which is same as b1, b2. All right. So you have the question is saying that you need to find out for which values of a both the methods are going to converge. It means they converge to your exact solution at some point of time. Okay, very close to exact solution. So what is your h in this case? H is just your 1 minus a minus a1. So that the condition I've said that if the eigenvalues are strictly less than 1, then we say that these methods converge. So the eigenvalues of h are, so if I use the previous thing, if you have to find out the eigenvalues of h, then use these two things because sum of eigenvalues is the trace and the product is the determinant. Okay, lambda 1, lambda 2. So so you can say lambda 1, 2 minus lambda 1, 1 minus a square. Or if you see that, then or you can find out easily using that. So lambda is a minus a, and you say that absolute value of a should be less than 1 for the methods to converge. So sometimes this thing works because it's kind of complicated a bit here. So rather go by direct. If this doesn't solve it, then go by direct way determinant of h minus lambda is 0. So there are two ways you can go with. All right. And hence mod a should be less than 1. That's it. Anyone has any issues in this? Is it clear, everyone? All right, if that's the case, we just go with, okay, yes. So another method is the eigenvalues and eigenvectors that I'm going to discuss. But if you have any questions, just let me know. For the time being, then we discuss the another things, a theorem and something like that. Any problems till now? Okay, so there is one important theorem I think that is being discussed in your classes as well, and there may be some questions on that, so be prepared for that. So very important theorem, Gershgorin theorem, which says that the largest eigenvalue in modulus of the square matrix A cannot exceed the largest sum of the moduli of elements along any row or any column. So okay. So what does it say? Lambda is the eigenvalue and it cannot exceed the sum of the coefficients on the top row, bottom row, any row. Okay, so this is very important thing that you need to remember. And um, other thing is also like this one is also important. PKB the sum of moduli of elements. Then every eigenvalue lies inside or on the boundary of at least one of the circles. So if pkb is the sum of modulus of the elements along the kth row, excluding the diagonal element akk, then if you subtract this diagonal element from your eigenvalue, then its modulus should be less than equal to pk. So I just go with one question based on that. So it helps you to give the bounds on the eigenvalues. Suppose you are given the eigenvalues. Oh, you have to find out the estimate the eigenvalues of matrix using the Gershgorin bounds. So you need to find out the bounds. So the first thing that you notice from here is that lambda cannot exceed, if lambda is eigenvalue of A, it cannot exceed the maximum modulus. So what is that? 1 plus 2 plus 1, 1 plus 1 plus 1, or 1 plus 3 plus 1. So it's just 1 plus 2 plus 1 plus 3 plus 1. So lambda cannot exceed 5 and lambda cannot exceed 6 as well. Okay. So where this is coming from, by the way, 4, 5, 5. Yes, so along any column you have to see as well. So this is along any row, maximum along any row, and maximum along any column. Did you understand this, by the way? I just tried it. Submit. Suppose that is your bounds. Suppose your A is just um, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then the maximum eigenvalue cannot exceed the maximum row sum. So what is the maximum row sum? What is this sum? Maximum should be 7, 8, 9, right? 7 plus 8 plus 9. And it also cannot exceed between the columns. So maximum column, that is 3 plus 6 plus 9. Okay, so that's it. All right. And similarly, it also says that there are two things. You have to take union of circles. Union of circles, it means that lambda minus 1 should be less than equal to 3. So you take this diagonal entry and subtract it, and then it is less than equal to other sum. Similarly here, similarly there. So you get this. And similarly for columns as well. And then you just have to take your intersections and make the plot like this, and you get the bounds. So the other thing is saying is, so just pick this, I just use the black color, just pick these entries and subtract from lambda minus 1 should be less than equal to your 3 plus 2. Lambda minus 5 should be less than equal to 4 plus 6. And lambda minus 9 should be less than equal to 7 plus 8. So these are another things. And similarly, you can do for 4, 7, 2, 8, and similarly for that. Then you take the intersection of these things, and then it gives you the bounds of this. So you got kind of three regions, 1, 2, and 3. Just intersect them and take the intersection one. That will be your final region. Is that clear, everyone? Is that clear, everyone? Okay, so the another method that we're gonna discuss is Jacobi method for symmetric matrices, but not now because it was too much for you guys and you may practice those questions And if you have any questions, just let me know for the while. I will take the doubts for another 15-20 minutes if you have anything you want to ask. You can wait and ask. So I've discussed the direct methods to find out the solutions of the system AX equal B that we have discussed already, the LU decomposition method, one question on that, Cholsky method, and other methods as well, Gauss elimination, Gauss Jacobi, right? And the other thing that we have discussed is iterative methods, which are basically based on iterations. So in any case, you need to have, means for iterative methods, you really need to have one initial point to start with because it is absent in your direct methods because you are finding the solution directly in that. But in these methods, you need your initial point, x naught, y naught, whatever. And then you start your second iteration, third iteration until you reach. But in every question in your exam, like they will ask like how much iterations you wanna do for like 1, 2, 3, or they will not ask for 10 iterations because it will be so complicated. So they will ask for only few iterations. And I've discussed eigenvalues, bounds. That's also interesting if they can ask something on this. So the main thing is to learn the techniques. That's very important in this. Yeah.
Hello, sir. Good evening, sir.
Yes. Hi,
Sir,
Nasir.
hello, sir. Can you just
Yes.
elaborate this spectral radius? Is spectral radius mean highest eigenvalue? Is it so?
Yes, I've discussed this right before, I think. Let's just go with in the last class.
And one, sir, just now the concept we discussed about the bonds. Are we taking
Yeah.
sum of modulus, or only sum? Are we summing them, or it is sum of the modulus for
Some
finding
of the
the
modulus. Some of the
modulus?
modulus. If you look at
And
this
and it is
here.
irrespective of, it is irrespective of whether it is diagonally dominant or not. We can always think of having a bond for eigenvalue, whether the given matrix is
Yeah. Yes.
diagonally dominant or not.
Yes. You can
So it's
always
not going to
do that.
depend on the diagonally dominant nature.
It doesn't depend. But if your matrix is diagonally dominant, then your methods converge. That's also,
Yes,
I
sir.
think, a theorem. Yeah, but I haven't discussed. But you are saying about spectral radius before? Just
Yes, yes.
so spectral radius, has this been discussed in the class, the SOR method? I don't know. Okay, spectral radius, I go with one. Okay, yes. So the number is, if you see here, rho h is the spectral radius, where rho h is the maximum absolute eigenvalue of h. Somewhere. I think there's nothing written over there. Yes. So rho h is just your, I just go maximum absolute eigenvalue of h. Is that clear?
So it means first I have to find.
Oh, then you
Sir,
have to take log tan as well in this case. Sorry.
my see now here, let us suppose I have got a matrix A. For that we
Yeah.
have determinant of A minus lambda I is equal to 0, where lambda is the
Yes.
eigenvalue. So now, depending on the order of the matrix, I will
Yes.
get number of eigenvalues, and it depends.
Mm.
It can be repeated, or it can be distinct, or it can be imaginary.
Lambda 1, lambda 2, and lambda n, say.
Yeah. Now since so it now even this which matrix was that rate? The one matrix, yeah, H is now for Seidel method. H is minus of inverse of L
Yes.
plus du into U, and for
Yes.
Jacobi it is different.
Yes.
So mean to say that to find the spectral radius, I
Yes.
have to always find matrix H, and that highest value is going to decide
Yes. Absolute.
absolute value.
Yeah.
So,
Of this.
is it the eigenvalue of A?
No, H should
It's
be H.
eigenvalue. Okay, convergence matrix.
Yes.
Okay, convergence matrix.
You can find H from A, I think. Is it? That- That's also sometimes A is H, but directly you can see. But if no, if it's not, yes. But yeah, H is different for each methods. Yeah. Okay, I haven't tried this H over here, isn't it? Which H I have used? Wait a second. I just have done something. So here H is your, yeah, H is different. So this one is wrong actually. I have written just A over here. So this is not your H. This is, so H is given by the method itself. H is, yes, T plus L inverse U. So you can find out, and this will match with this one. 0 A 0 A 0. Yes, I think it was complicated, but all right. Thanks for pointing this thing. Difference between H and A. Yes. Any other doubts?
And so one more thing is, if at all the given, let us suppose both the iterative method which we have been thought of, it will be Seidel or just Gauss-Jacobi. If they are diagonally
Hmm.
dominant, we can always assure that it will converge irrespective of whatever the initial condition we give.
Yes.
If
Yes.
diagonal dominant. In
Yes.
case, because Professor also saw, Professor Amit sir also showed many example
Hmm.
during the MATLAB, and he was running the code as well, and he
Hmm.
was giving examples where it was not diagonal dominant, and whatever initial guess was taken, it was not converging. So always for both the procedure, diagonal dominant should be there.
Yes. Yeah, and if you can prove that with the diagonal dominant that the eigenvalues of the iteration matrix is less than one, then yes, it converges. Because for, I think for diagonally dominant, it's true. The eigenvalues are less than one, absolute. But they won't ask you for the proof in the exams, just you need to remember things. But if your method is convergent, then it doesn't mean that your matrix is diagonally dominant. Just remember this. It's just a, what you say, one-side condition. Yeah. But you can definitely say if your method is convergent, then eigenvalues of iteration matrix are less than one. Absolute eigenvalues.
Sir, can you just elaborate this positive definite matrix? Positive definite matrix. Can you just elaborate?
Yes, yes, sure. So I just go with, so positive definite is just if you have a matrix A and by n, then you say an is positive definite if x transpose ax is greater than 0 for all x in for Rn cross 1. That's the easy definition. Or you say that eigenvalues of A are strictly greater than 0. Is that clear?
Can you just give an example, sir?
Yes. So if you take one identity matrix is definitely a positive basic example, and other matrix is any diagonal matrix if the diagonal entries are greater than 0, it's also positive. So you just check the matrix and check whether the eigenvalues are strictly greater than zero in that case. Yes, I think so.
So eigenvalue should be positive, but none of the
Yes,
entries. But what about the entries of the matrix? Should be always positive?
entries can be anything.
Okay, so now if you get any random matrix, how are you going to distinguish whether it is positive definite or not, sir? If you get any
Okay,
random matrix, how to judge it is
positive def.
positive definite
Suppose you
or
find, suppose A is given to you like 5 0 something minus 5, and you find some x such that x transpose ax is not greater than 0, then you say it's not positive definite. But if it's positive definite, then it should be greater than 0 for all x, or eigenvalues are strictly positive.
the x which should be taken can be any arbitrary x.
Any x, yes. If for any x it happens that it's x transpose ax is not greater than 0, then you say your matrix is not positive definite. Is that clear?
Yes.
Okay. Just seeing whether it's true. Like, means if eigenvalues are okay. Yes, you just say that um, eigenvalues are strictly greater than 0, then it's positive definite, yes. But you try to find out if you have to prove not positive definite, just try to find such x such that this happens. But anyways, or try to prove that eigenvalues are less than 0 or something. Anyways, you can do anything. Any other doubts? Any other queries? Others? Yes, Rakshita, you want to ask something?
No, sir.
Is that fine? All right. Like what I've taught today is okay. I hope you understood that. When is your exam? I think it's in May, right? So we have time. But practice more and more questions, I think, in your assignment, and so they may be similar to that. Just try that one. I usually follow these two books because they are pretty easy, and exams are also based on somehow on these books, I think so. Similar to these questions. But main thing is to learn things, not to just to solve the question. Just learn things. I just wait for another 10 minutes. If you have doubts, just let me know. I just wait.
एचबीटीयू तो नाम तो है ही उसका।